Hello and welcome. This video is all about titration calculations, and it's one of the topics that students do find very tricky. It's probably one of the trickier or the trickiest topic you'll come across in GCSE chemistry, but hopefully by the end of this video you may have, or you should have, a better idea of how to tackle some of the questions that may come up. Now the spec actually says that you need to be able to calculate quantities in titrations involving concentrations, which are in moles per decimeter cubed, and masses, which are in grams per decimeter cubed. And we should also be able to work out an unknown concentration if we have some data about the other reactant in a titration. Now let's just get that out of the way for a sec. There's a couple of things I want you to know before we actually carry on with the video, and the first one is that 1 decimeter cubed is a quantity that we worked with, we are going to work with, is exactly the same as 1000 centimeters cubed. So if I have 1 decimeter cubed of water, it's exactly the same as having 1000 centimeters cubed of water, which incidentally is the same as a litre, so it gives you an idea of how much we're actually talking about. The second thing I want you to know is that the concentration of a solution, for this video at least, is going to be measured in moles per decimeter cubed. So if I have 3 moles in 1 decimeter cubed, this concentration is 3 moles per decimeter cubed of whatever solution we have. The last thing I want you to get your head around, we have come across this before, but we do need to know and understand it, is that when we're talking about moles, the mass in grams of 1 mole of a substance is its relative formula mass in grams. What does that mean? If this is very confusing for you, you could go back to look at the video I did on moles in Unit C2, but I'll just give you a quick summary of what we mean by this. If we have, for example, sodium hydroxide, the mass in grams of 1 mole of sodium hydroxide is its relative formula mass in grams. The relative formula mass for sodium hydroxide can be calculated from the periodic table, and the way we do that is we'd look up the relative atomic masses. So for sodium it's 23, for oxygen it's 16, and hydrogen it's 1. And as I say, you can look these up on the periodic table, which you will have in your exam. So if we add these together, 23, 16 and 1, we get an answer of 40. So the relative formula mass for sodium hydroxide is 40. Now it says here the mass in grams of 1 mole is its relative formula mass in grams. So if we just put that as grams, we know that 1 mole of sodium hydroxide has a mass of 40 grams. You could do the same with something else. I don't know, hydrochloric acid, or this is hydrogen chloride. We have hydrogen as a relative atomic mass of 1, chlorine is 35.5, and again we're looking this up on our periodic table, and if we add those up, the relative formula mass is 36.5, and if we just change that to grams, we can say that 1 mole of hydrogen chloride has a mass of 36.5 grams. Okay, so probably worth just chewing this over, making sure you understand this, or making a note of it, because we're going to use it for the next slide. So here it says make a 1 mole per decimeter cube solution of sodium hydroxide, which is NaOH. The relative atomic masses are 23, 16 and 1. Well, we've done this already, so we've calculated that that's 40. And if we work out the mass, we just add a little g there. And if we want to make a 1 mole per decimeter cube solution of sodium hydroxide, all we do is we take 1 decimeter cubed of water, which is exactly the same as 1000 centimeters cubed of water. This would be distilled water. Just chuck in that 40 grams, stir it in, dissolve it in, and we have made a 1 mole per decimeter cube solution of sodium hydroxide. The next one I want to look at here is put 40 grams in 500 centimeters cubed of water. What is the concentration in moles per decimeter cubed? Well, we know that 1 mole equates to 40 grams, so we've got 40 grams in 500. How many grams would we have in 1000? That's simply double that, so it's 80 grams. But we know that this 40 grams relates to 1 mole, so 80 grams must relate to 2 moles. So the answer here would be 2 moles per decimeter cubed. You might see this sometimes just written as moles without the E and the S on it. Okay, same thing, don't get confused by that. The last question here says, what mass of sodium hydroxide is there in 250 centimeters cubed of a 2 moles per decimeter cubed solution? Okay, so we're still dealing with sodium hydroxide. We've got 2 moles in a decimeter cubed, and we know that that's 80 grams. So we've got 80 grams per decimeter cubed. How about in 250 centimeters cubed? Well, we know that 1 decimeter cubed is 1,000. 250 is a quarter of that. It's about down here. So we have in 250 centimeters a quarter of our 80, which is 20 grams of our sodium hydroxide, and that would equate to our answer. We don't need to do anything further because it's just asking us what mass of sodium hydroxide is in there. Okay, so hopefully you've got the hang of this slide. If not, just have another look at it. Now our next problem is slightly trickier, but still something that we can do if we go through it step by step. What I've got here is 45 centimeters cubed of sodium hydroxide solution, and its concentration is 0.2 moles per decimeter cubed, and that has neutralized some ethanoic acid. We have 15 centimeters cubed of ethanoic acid, but we don't know the concentration. Okay, and we assume here this question tells us that 1 mole of ethanoic acid reacts with 1 mole of sodium hydroxide. The question is asking us to calculate the concentration of ethanoic acid in the unit of moles per decimeters cubed. Now I'm going to show you a method to do this which might simplify things. If you have a method that you're quite happy with, you can go ahead and use that, but here's a method that you may or may not have come across. The first thing you do is this. So what I've done here is I've written acid on the left hand side and alkali over here on the right, and the concentration times the volume of the acid is the same as the concentration times the volume of the alkali. So if we know this is the case, it's just a question of plugging in the data from the question into this formula and working it out. So here we have our acid, which is our ethanoic acid. We don't know the concentration, but we do know the volume, which is given here. It's 15. We'll leave the units out just for simplicity for the moment, and that is equal to the concentration times the volume of the alkali. Now the alkali is sodium hydroxide. It has a concentration of 0.2 moles per decimeter cubed times a volume of 45, and if we just do that calculation over this side, we have 0.2 times 45, which is 9. So we have unknown times 15 equals 9, and if you're good at maths, you'll know and remember that to rearrange this, we say 9 over 15 is our unknown quantity. So 9 divided by 15, that gives us an answer of 0.6. Okay, so we want, that's our concentration in moles per decimeter cubed. So we might just write under there. Okay, so the next question is asking us calculate the concentration in grams per decimeter cubed. So how many grams have we got in there? Well, we know the relative formula mass for ethanoic acid is 60. That's been given to us in a question. That is 60 grams, which would equate to 1 mole. We've got 0.6 grams 0.6 moles per decimeter cubed. So we have 60 grams in 1 mole, but we've got 0.6 moles. So all we do is we say 0.6 times 60 equals, I believe, oops, not 0. 0.6 times 60 equals 36 grams. And remember, it's grams per decimeter cubed, because it's asking us to calculate the concentration in grams per decimeter cubed. Okay, so that's another question there. Let's try one more. This one I think is probably worth you having a go by yourself, and then we'll go through the answer in a moment. So here's the answer. I've written out our little framework here. Concentration times volume of the acid is equal to the concentration times volume of the alkali. So we're just plugging in the numbers. Now what we have is a titration is done when 25 centimeters cubed of acid is placed into a conical flask. The concentration of the acid is not known. So here's our acid. We have an unknown concentration but a volume of 25. And for our alkali, the acid was neutralized or reacted completely with 13.5 centimeters cubed of sodium hydroxide, which is our alkali. So we have 13.5 centimeters cubed over here, and the concentration is 0.1 moles per decimeter cubed. So again, if we do our calculation, we have 0.1 times 13.5, which will give us 1.35 over here. So this is our next line, and rearranging as we did before, we would have 1.35 divided by 25. So our answer is, I believe, 0.054. And what's it asking us to work out is the concentration of the acid. So it's going to be moles per dm cubed. So we can just plug that into our little gap here, and there's our answer, moles per cubic decimeter. That's just the same way as, again, as saying moles per decimeter cubed. Now the next problem is slightly different. Here we have a titration is done to find the concentration of sulfuric acid. So sulfuric acid is the one that we don't know. 25 centimeters cubed of the sulfuric acid was neutralized by 34 centimeters cubed of potassium hydroxide, and the concentration of the potassium hydroxide is 2.0 moles per decimeter cubed. And they've given us an equation here. Here's our potassium hydroxide and here's our sulfuric acid. But what we can see is that we have a balanced equation that tells us that two quantities of our potassium hydroxide reacts with one quantity of our sulfuric acid. We can tell that because we've got two here and we haven't got one here, but that just means one quantity. So we could replace the word quantity by mole, so we can see that 2 moles of potassium hydroxide reacts with 1 mole of sulfuric acid, and we need to take that into account when we do our calculation. So again, we can use what we used before, and there it is. Here's our acid. Our acid concentration is unknown. We have a volume of 25 given to us in the question, and for our alkali we have a concentration of 2 moles per decimeter cubed and a volume of 34 centimeters cubed. So we can just do what we did last time. So this is 68 and to do our calculation we can just say question mark equals 68 divided by 25, and that gives us an answer of 2.72. Now that's our answer, but remember it's not our final answer because we have 2 quantities of potassium hydroxide reacting with 1 quantity of sulfuric acid. So what we have to do is actually half that figure, and when we half that figure we get 1.36, and that's the concentration that we want in moles per decimeter cubed. So the unit is moles per decimeter cubed there, and that's our final answer for that question there. So quite a long video there, lots to digest. Probably need to go over it 1 or 2 more times. What I might do on the actual notes for the website is I might delete all the working out that we've done so that you can have a go again by yourself at a later time, just to make sure that you understand it. But other than that, that's me done for this video. Thank you for watching, and I'll see you again soon.